Hello, everyone. My name is Hannah Kang. I will present Mapping Korean National Health Insurance Reimbursement Claim Codes for therapeutic and surgical procedures to City to facilitate data reuse. I'm very pleased to have this opportunity. South Korea introduced universal healthcare coverage in 1989. As of 2019, 97% of the population is covered by the National Health Insurance and 2.8% by medical aid. A single-payer system was introduced in 2000, and by law, all the healthcare providers are obliged to participate in the NHI system as providers under the NHI and cannot opt out. About the NHI claim code, as of 2019, there were about 10,000 of codes in 19 categories, including therapeutic and surgical procedures, basic medical examinations, evaluation procedures, diagnostic medical imaging, dental services, palliative care, and so on. Therapeutic and surgical procedures were selected for this study as a part of the project Support for Standardization Development and Spread of Electronic Medical Record System Certification Standards 2019. South Korea joined SNOMED International as the 39th member in August 2020. To expand the use of City, Korea Health Information Service is carrying out projects such as data-driven hospital, reference set development, EMR certification system that uses standard terminology as one of the certification criteria, and mapping standard terms in use to City as in this study. The purpose of this study is mapping therapeutic and surgical procedure codes of NHI reimbursement claim codes to City to facilitate the reuse of health insurance claim data for clinical research. The source codes are 2,500 codes for therapeutic and surgical procedures covered by insurer for treatment and surgery, such as general treatment, endoscopy, emergency treatment, interventional radiography, dialysis, cast, and surgery. The target terminology is nomicity, and the map target concepts of this study were restricted to the procedure top-level hierarchy based on the domain of the source codes. First, we prepare the source codes to clarify meaning of the codes and search. Next, we search its nomicity browser to map to pre-coordinated concept or to express the source code by post-coordinations. At last, we validated the result internally in the research team and externally with the experts. For data preparation, first, we gather the information provided by the Health Insurance Review and Assessment Services portal. In the portal, they provide text definition of the procedure, target, means, and action of the procedure, and claim use cases, such as when to use the procedure and a detailed description of the procedure. Also, we translated Korean term of the source code into English when there is no English term provided or the English term is inappropriate for searching. In this study, we shared and followed these principles for mapping. First, When a source code included multiple procedures, they were dissected into unique concepts and mapped. Second, we did semantic mapping, not lexical mapping. Third, the source codes were mapped to the concept of procedure hierarchy. Fourth, when a source code was not mapped to a pre-coordinated concept, we represent the characteristics of the source code by post-coordination with attribute value sets. When mapping, 4 registered nurses who majored in nursing informatics with at least 3 years of experience in SNOMED city mapping participated. They had performed SNOMED city mapping in a previous research project that involved mapping local terms from EMR records or mapping other standard terms in different domains. The mapping was conducted in 2 teams. 2 mappers assigned to each team and mapped half of the source code independently. The type of mapping results can be characterized as the figure, except the case of not mapped. When we search the SNOMED city browser, we first try to map the semantically equivalent pre-coordinated concept. When the source code includes multiple procedures, they were mapped separately. Only when there is no semantically equivalent pre-coordinated concept, we tried post-coordination to express the source code closely to the meaning, even if the post-coordinated expression cannot fully express the source code. The map cardinality is categorized by the number of target SNOMED city, pre-coordinated concept, or post-coordinated expressions. After the categorization of expression and the cardinality, the map correlation can be categorized as exact, narrow to broad, and partial, as in the next slide. In terms of semantic equivalence, regardless of its expression or cardinality, a source and a target have 3 relations from the standpoint of the source. First, a source and a target can be exactly matched. Next, a source can be matched to the target with broader meaning in the map. Finally, a source and a target can be matched to the narrow target or partially overlapped with the target. In this study, we did not map to narrow target to avoid information loss, so all the partial matched results were the last cases. The map were validated internally and externally as shown in the figure. For internal validation, the mapping results of the 2 mappers were compared with each team after they had independently performed mapping. When the 2 mappers agreed with the maps were considered internally valid. If they disagreed with the maps were discussed in the group meetings attended by the project manager and other researchers who were not involved in the mapping process. Group meetings were held throughout the study period and were attended by an average of 5 researchers with experience of SNOMED city mapping. The most appropriate mapping for the map for which there was disagreement was discussed and then decided. Consistency with other maps was also considered in this process. For external validation, some of the maps were extracted and validated by 2 physicians with experience of SNOMED city mapping, but who had not participated in this mapping process. They either agreed with the extracted map, or suggested a new map. The result of mapping between the therapeutic and surgical procedure codes and SNOMED is presented as the graph, categorized by map expression, cardinality, and correlation. In terms of expression, 52% of codes were mapped to pre-coordinated concepts and 48% of codes were mapped to post-coordinated expressions. In terms of map correlation, we could semantically exactly express 64% of source codes to SNOMED pre-coordinated concept or post-coordinated expressions. We expressed 36 of the source codes to broader SNOMED pre-coordinated concepts or post-coordinated expressions, and the rest to partially overlap pre-coordinated concepts or post-coordinated expressions. There were 2,007 attribute value pairs used for 1,202 post-coordinated expressions corresponding to an average of 1.7 coordinated attribute value pairs. There were 14 types of attributes used for post-coordination, as well as 4 subtypes, as shown in the figure. The most commonly used attribute type was procedure site. The next was head focus, and the third was procedure morphology. The maximum number of attribute value pairs used to express a single code were 3. Angioplasty of blood vessel with artificial graft using surgical patch by thoracotomy is an example. We express the source using pre-coordinated concept, angioplasty of blood vessel, and we post-coordinate 3 attribute and value pairs as shown in this slide. In this study, the following challenges were encountered due to the characteristics of the source codes. First, the Korean and English terms of the source codes were ambiguous, so that we had to clarify the exact meaning with additional information and translate the terms. Also, multiple procedures were assigned to one code if the premiums paid were the same for the convenience of claiming, which required post-coordination. South Korea has future plans for SNOMED. Korea Health Information Service is planning to expand use of SNOMED in South Korea as the National Release Center. The institution has a 5-year roadmap for expanding the use of SNOMED, including SNOMED education and developing SNOMED reference sets, such as cancer reference sets. We are expecting to be capable of collecting information at the point of care with SNOMED. This study was funded by the Korea Health Information Service as part of the project Support for Standardization, Development, and Spread of Electronic Medical Record System Certification Standard 2019. Thank you for listening my presentation. If you have any questions, please let us know by email. At last, I want to thank my advisor, Hyunhee Park, who always supports me in many ways. Thank you so much.